Welcome back, everybody. This is a Gyruss PCB set. And I just got this out of the box and put it down on the board or bench and started looking at it. And just kind of looking over the back of the board, making sure there's nothing funky going on. And I'll show you right off the bat something that I see. You see this. You see that right there? That looks an awful lot like two leads shorted together. I don't know the significance of it. This is just preliminarily looking at the back of the board, and I saw that. I just wanted to point that out. Always look for that kind of stuff. So I'll go ahead and separate those guys and continue looking at this, and then hook it up and we'll fire it up. See what happens. Okay, we got our Gyruss board set hooked up. Obviously the sound is sounding good. It looks like our problem is a sprite problem. You can see there's really no sense being made here. So that's just really messed up. I think the first thing I'll do is I will just reseat the ROMs, which I don't think is going to make any bit of a difference because this is a catastrophic failure right here. It's just, there's nothing going on. We got some major problems here. Yeah. So I'll have to do all what I normally do. I have to go through and pull up the schematic and download the schematic, download the pinouts so that I can turn off this demo music, and go from there. Start looking into the video section of this board. So, all right. Well, we'll get to it. All right, with this Gyruss board set, what I did was I pulled the Time Pilot board set back out and I tested all of these custom chips in the Time Pilot board, and they're all good. This is the only one that's not on Time Pilot, so I couldn't test this one, so I hope it's good. But the rest of them, there's 1, 2, 3, 4, 5, 6. 6 of them on that board they're all good. So yeah, so I'm gonna have to look at the schematic. I might have to pull this Z80 and see if I can write to the video RAM and stuff. That'd probably be a good place to start, is put the fluke on this thing and see if I can get to the video RAMs and stuff like that. But I think first I'll just look at the schematic and see what's going on. Okay, after briefly looking at the schematic here just a little bit, I think a good place to start is going to be accessing the Z80's bus with my fluke. So I am going to desolder the Z80 out of the board, socket it, because I want to be able to, there's a lot of circuitry. I mean, it's typical of video hardware. I'm just going to test the video hardware by making sure I can read and write to the RAMs. So that's what I'm going to do first, is just make sure that the CPU has a path to all of the video part of the board that it needs to. And these guys right here are the muxes that you got a lot of circuitry right here, and then it makes its way to the muxes, and it's muxed together right there, and that's where the addresses are made that access the video RAM. So by testing with the Fluke the video RAM, I'm testing all of the circuitry basically. So yep, that's what I'm going to do just here in a second. I'm preparing to desolder that Z80. Okay, I'm back at it. I got this thing turned on. I have here this is the Konami 1 CPU, which is basically it looks like a 6809 CPU. And I've got the pinout for it wrote down here. I'm going to test around on it. It's involved in video some way, just by looking at the schematic I can tell. And I was doing some probing around on the board here, and I came across these two guys, these 245s, which are here and here, and the direction pin is always high, and it shouldn't be. Is by looking at the schematic, these 4 RAM chips right here are accessible by this guy, and the data passes through these two 245s to get to these guys, and there's nothing passing through here. There's nothing going on. There's no signal to the direction. And if you looked at the schematic, you'll see that the direction controller for these two guys are what are called X enable and Y enable, or something like that. And they're non-existent, and they come off of, they're basically derived off of this guy's read-write signal, which is non-existent. Pin 13 is supposed to be this thing's read-write signal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it's just high all the time. And that's supposed to be read-write. So read-write comes off of this, and it goes immediately over this 367. And I clipped the 367 lead, thinking maybe it was, I wanted to eliminate, is this holding it high? So I clipped the lead that this is connected to, and it didn't change anything. So I'm just going to repair that. But I'm going to go through and check all of the control signals to this guy. I mean, it's addressing is working fine. 1, 2, and 3 are addresses, and then 30 through 42 are addresses. We've got activity on all of them, and data bits 0 through 7 are on 12. So here's 12. Pin 11, I don't know what that is. I don't have anything on it. I don't know what that is. Okay. Anyway, these are data bits. So there's activity on the data lines. Those are the 2 clocks. The E and Q clock. That's 17. That's reset. 20, 21. Okay. That's ground, 22. This is non-maskable interrupt, which is, I have to look at the schematic and see if it's pulled high. There's no interrupt. This thing is constantly in interrupt, it sounds like. This is interrupt request. Well, that's interesting. Interrupt request is constantly low. So I think what I'm going to do is this IRQ, it's 21, 22, 23, 24 is low. Yeah, that's interrupt. 21, 22, 23, there is no non-maskable interrupt, but that might be pulled high. 24, the IRQ line, I would think should have some kind of activity on it. Because I have to find out, why is this custom not putting out a read-write signal? Because that read-write signal goes to some other logic and is gated to create these enable signals for these 245s, the direction, so that this thing can communicate with these RAMs here. So I'm going to go ahead and I'm going to repair this. I clipped a lead. I might have to replace the chip. I don't think I left enough lead to get to. So I might have to replace that guy. And look at the interrupt portion of the schematic for this guy. See if it's pin 24, 21, 22, 23. Yeah, it's held low. If anything, it would be pulled high. This should not be held low. The FIRQ on 25, that could be pulled high. But this interrupt request should not be held low. Non-maskable interrupt, that might be held high. Okay. The IRQ signal I have to look at. So let's get to that. I'm going to pull a schematic up and look at that and see what's going on there. Fix this guy, fix that trace I cut, and see if we can figure this out. Okay, and this guy right here is that 42 pin custom. And you can see right here is IQ. That's the interrupt going in on pin 24, which is pulled high until it's driven low. And remember, it was always low. So it's just, I'm going to have to search this schematic and find this signal. And find what is making that signal. So that'll be fun. Looking at this schematic gives me a headache, I'll be honest with you. But yeah, I gotta find, we gotta get a read-write signal coming off of this guy, and right now it is always being interrupted. This is held low, so this isn't gonna do, it's not doing what it should. So let's figure that out, find that signal, and go from there. Okay, right up here in the schematic is that IQ signal right there. And it's 18E, which is a 74 flip-flop. And it's looking like these two flip-flops are working in tandem with each other. It's the same chip, 18E on both, it's a dual flip-flop. It looks like it starts here. You got Q, data bit 0, Q, IRQ. That's your data input, and that's your clock. You got preset is pulled high, and pin 1 is hooked to reset, so it'll be high. It'll always be high unless it's reset. And those two create a pulse. It comes over here and it sets this guy. The data is always going to be low on this guy, and it's getting clocked by this 816 signal. And the clear is pulled high. So what this is going to do is this will always be low unless this is set to 1 by this guy. This sends a low here, and that'll set this to 1. And then it's going to be, as soon as this goes back high, this will be clocked back to low. That's how this works. It goes low, high, based on this signal and the clock. And what I've observed is this isn't doing anything. There's no inputs, no data input, no clock input to this guy. And I'll show you that. We come over here. That is 18E. That's this guy right here, 18E. So if I take my logic probe and go, this is pin 11. This is that 816 signal. So we're getting a good clock to this thing. And remember, this is the data line, which is always low. It's held low. In pin 10, this is the preset line, which this flip-flop on the other side is supposed to set. It's supposed to pulse this low to set Q to 1. And over here, pin 2, that's the data line. That's that Q data bit 0 or whatever it was. And the clock is always high, which is QIRQ, I believe. So this isn't doing anything. So I need to look to the inputs on the other side of this flip-flop, that Q data bit 0 and QIRQ. I need to find those. Why aren't those pulsing this flip-flop? And just keep going one step at a time backwards and finding out what's going on. So let's do that. Let me look at the schematic, find those two signals, and try to figure out what's going on. Okay, I decided to go ahead and hook up the analyzer to that 74. And I'll show you on the schematic again where I'm hooked up. I'm hooked up to this right here. So I'm analyzing this data signal, this clock. These two are always high pretty much. And I'm on Q and Q naught. So we'll come over here and look at what I'm looking at. And I have this thing set at 200 nanoseconds, which is it should be shouldn't be too fast for this thing to be working, basically. And this is your clock pulse. You can see how I got them labeled. Your clock's coming in like a train right here. And the data coming off of the ROM is a lot faster frequency, basically. But this clock pulse, you can see right here, this is low, but it stays high. I mean, it should have toggled right here. So this should be toggling to create that that interrupt for that 42 pin guy, that custom. So this thing is missing pulses, I believe. So I'm gonna replace this 74 and see, because according to this should be pulsing. So, and it's not. Let's go ahead and replace that guy right there. Okay, real quick. I replaced this guy right here, and that's the data line. That is the clock, and now I do have pulsing on the outputs, and this side is also now pulsing. But we're still messed up. So there's still a big failure. But at least this is showing life now. So that 74 was not working right. So now that we got this replaced, we can move on to something else. Okay, so now that this is going, let's check 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 is still stuck high. There's still no interrupt to this guy. So I'm going to have to re-look at the schematic now because I kind of forgot what was going on with this. I kind of forgot what was going on, so I have to re-look at the schematic and find out, kind of revisit that interrupt signal to this, why there's no interrupt to this guy. But at least we did replace this. We got some activity back on this chip, so that's good. It's one step. Alrighty, I'm here at the Gyruss board. Let me turn it down. And it's, you can see it's all flaky. Flaky, flaky, flaky. And I am on a 139 right now. And I am not on a 139. I'm on it backwards. Well, I'm going to film this anyway to show you my mistake. I am hooked up to this as if pin 1 is over here. I'm thinking that's pin 1, and I'm like looking at this and I'm like, okay, this is the enable line. Why are these all toggling when it's not enabled? Let me hook this up correctly. Be right back. Now I am hooked up to it correctly on the right side. And you'll see it looks like it is working just fine. I got it stopped here at a snapshot. You got the enable line. This is enable. So it's going 1, 0, 1, 0. When it's 0, it's enabled. This is the select. So it's selecting 0. Now it's selecting 2 for this whole block. And it's enabled 3 times, here, here, and here, while it's selecting 2. So line 2, right here, is 0, 0, 0. And then again over here, selecting 2. So 2 goes 0. Now I'll go ahead and grab another snapshot, and you'll see this whole time it's selecting 0. And it enabled, 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 enabled. And every time it enables, it sends 0 low. So that guy is working. Let's just free run it a while. And you'll see the different changes it does. It's doing its thing. So that guy is working. Now this is a dual decoder, or yeah, it's a 3 to 4, 2 to 4 line decoder, something like that. It's got 2 of them in it. So we're going to hook up to the other side, and make sure that guy's working right. Check and control signals. Okay, I'm on the other side of it now, the second part of that chip. And you see, once again, it is working correctly. The curious thing about this, though, is the only two signals coming off of this are 0 and 1. And 1 is never being selected. And you'll see with the select line, you never see 1 up on the select line. So it's just never selecting 1. It's either 0, 2, or 3. But that doesn't tell me that this thing isn't working. This thing is working fine. There's just something missing. There's something missing in this to trigger line 1 to go low. So this is not my problem. And what I'm looking at, I'll show you what's going on here. I just analyzed these two guys right here. This is the same chip. It's a 139. This is one part of it. This is the other part of it. These two signals were present. This line 11 here is the one that would never trigger low. But it's not because this is bad. It's just not selecting it. So, yeah. Just going to have to keep digging. And keep looking at these control signals. The problem is in here someplace. These RAMs are getting, there's no business going with these RAMs. I'm going to keep poking around in this this section and just keep looking. I am probing around on this board, and I have probed an awful lot of this board. I got a lot of colored dots all over the place. And everything is looking perfect, just looking great on this board. And I'm just not finding anything that looks bad, really. So I decided to isolate this board from this board over here. I unplugged it. And I don't know if you remember, but pin 13 off of this guy was the read-write signal that starts a big chain of events that gets a lot of stuff working. Like the read-write signal that go to these RAM, which is now working. And pin 13 on this guy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, you can see is now busy. So it's awfully funny. I isolate this board off of the system and it seems to be working perfectly. I got good signals coming out of these RAMs now, which I had no signals coming out of these RAM chips. I had no signals, no direction signals on these 245s right here. Now I have direction signals on these 245s. And this board has just come to life. There's something on this board that is wrecking this board. My problem is on this soundboard, I believe. Which is a very... I didn't suspect that. So I'm going to look at the schematic of this guy and see what is going on here. I'm going to have to do some studying to find out what that could be how this board is talking to this board. What signals are going through. What signals would kill this board? So let me do a little studying. I gotta look at the schematic and go over that, and look at the relationship between these two guys. Well, when I last left you, I had put this board aside because it was acting right when it wasn't hooked up. Well, that was this thing every now and again will make you believe that it's working right. But I did a little testing with just this board, and there's nothing wrong with this board. It's this board. This is the problem. So I'm just going back to the buffering, and I'm on a 367 right now and checking that out, and I will show you what it's looking like. I got it triggered on enable, so it's triggering on enabling, and you'll see when it's enabled, when this pulse is low, your input should go to the output, and you can see for the most part it looks pretty good, but there are times when it doesn't. See that? This line 1E31 OF, that when this is enabled, that should go straight to the output. And for the most part it does, but there are times when it doesn't. And I don't like that. So I'm going to try to clean that up by replacing this chip. Yeah, there are times when it just doesn't match. So let's go ahead and I'm gonna move this over to the brand new one I put in right here and see how that one looks compared to the old one. Okay, I have been, as you know, I've been poking around. I've been analyzing latches and buffers and everything. I mean, there's a few little things that are bad, but like I replaced this guy that we were analyzing where every now and again it would be different, and I'm getting the same results on this one, so it's just a timing type deal. It's not actually bad. But what I have here, I have it running, and you can see it's doing the same thing it has been doing. But I have removed and put sockets in the place of this RAM and these 4 RAMs here. And without those RAMs even in the board, I'm getting the exact same thing. I'm going to go ahead and restart it. And you'll see it come up. It comes up with all the character data in the North America and South America here. The sprites are the globe around it. But all the character data is it's just sprites are non-existent. And I removed all of the RAM that is involved in the sprites, and I'm going to put new RAM in these spots and see what happens. Okay guys, I have populated these RAM spots, okay, and I turned it on. As you can see, we are now fixed. It's just absolutely bad RAM. The process of elimination, I got down to it's just got to be RAM. And this is a case where jumping RAM over the RAM did not work. Because I was trying to piggyback RAMs over RAMs and it didn't work. So This was just removing these sprite RAMs. This guy right here is a 6809 basically. It's called a Konami 1 processor. It's an encrypted 6809 is what it is. And this section is the sprite section. This guy loads data into these guys, and that data is used to address these guys. I believe these are the sprite ROMs. I'd have to look at the schematic again, but I was studying the schematic, and this is all sprite. This RAM, these RAMs, these ROMs. This guy controls all the sprites. This Z80 does all the program processing and dumps data onto this board here. This guy, this 6809 Konami 1 processor runs the sprite data. Yep. And the CPU handles all this this stuff too, the character type stuff, I believe. Or the character, I don't know about that. I'd have to look at the schematic again. Like I said, what I was really focused on was, I know this is character data area over here. And I know this is sprite. This is all sprites. All this stuff. You got your muxing for the addressing here. I think this is the muxing for the addressing to this guy, I think. But, yeah, so that's it. It's just bad RAM. This is a bunch of bad RAM. See, there's that globe. Pretty cool. And we know our sound's working good, so cool. Yeah, the reason why, if you're familiar with Gyruss, the reason why you're not hearing all of the sounds is this is a 2-channel soundboard. It's a stereo soundboard, and I've only got 1 channel hooked up. So I'm only getting 1 channel of the audio. Alright. I think what I'm going to do is I'm going to find out exactly which RAM were bad. I'm going to plug in these RAM and find out which of them were bad. And I have narrowed it down to these 2 guys. These 2 RAMs were mucking up the works. So I got 2 originals and 2 new ones in. This guy was okay. It was just those 2 guys right there. Yep. And that is it, guys. Alrighty, I'll let this one play through for a while, and then call it good. I'll give it I don't know, I'll let it run for a few hours, just leave it on. Make sure these RAMs aren't going to flake out, these other 2. I mean, eventually they will, but they're good now, so we'll use them until they're no good. But you know, if you lose sprites completely, look at these guys, or this guy. So, alrighty, we'll see you on the next one. Thanks for watching, guys. If you like this kind of stuff, of course, subscribe, give me some comments, some likes, and we will see you on the next one.